Okay, so the final piece that we will look at is the effect of a catalyst. The effect of a catalyst. So I'm showing a reaction diagram. So this is a single step elementary reaction, right? Because we have one hump, which indicates a single step, right? It only goes through one transition state. So the red line here is showing the reaction progressing from reactants, activated complex or transition state to products without a catalyst. And the blue line is in the presence of a catalyst. We're showing the activation energy for the forward reaction for both the reaction in the presence and absence of a catalyst. And then we're also showing it for the reverse reaction, right? Where our product becomes the reactant, and we're showing the activation energy for those reverse processes. So we know that, right? We previously talked about a catalyst lowers the activation energy, which we see right here, right? We have a lower activation energy when we add a catalyst, going from this red to blue line. Because a catalyst lowers the activation energy, the reaction speeds up, right? Because it has to overcome the barrier that it has to overcome is smaller, it's lower in energy. So the reaction speeds up and the rate increases. As a result, equilibrium happens more quickly. However, the equilibrium constant remains unchanged. So adding a catalyst does not change the equilibrium constant. And if you think back to what our expression is for equilibrium constant, which can be written in the form of based on concentration or Parser pressure, K sub C or K sub P, it's based on the amounts of our products and reactants, right? By definition. And those are not changing as a result of a catalyst. What is changing is the activation barrier, right? And so as a result, addition of a catalyst does not change our equilibrium constant, even though it does increase our rate and results in equilibrium happening more quickly. So, to conclude, we talked about 5 different stressors on an equilibrium system: concentration, pressure, volume, temperature, and catalyst. And we looked and we applied Le Chatelier's principle to see when we change any of those or when we introduce any of those stressors, how will the system shift in reestablishing equilibrium? And you may have noticed that the same stressors are the same things that also can change our rate of reaction that we talked about during our kinetics, right? Temperature, concentration, pressure, catalyst also impacts our rate of reaction as well. So these also will impact our equilibrium. All right, that concludes equilibrium.